In an original 1920s factory building, B.A.C. Musical Instruments is situated in Kansas City's historic Jazz District. We're right across the street from the iconic 12th Street and Vine intersection, where legends such as Charlie Parker, Benny Moten, Lester Young, and Count Basie all helped to refine what we now know today as America's music. B.A.C. Musical Instruments was set out to preserve an important American legacy of manufacturing brass instruments. But we also have a very deep level of respect for the historic significance this neighborhood had to serve our music community. And in the same innovative spirit, we're very humbled to continue that same tradition today. Hi, my name is Mike Corrigan, founder and president of B.A.C. Musical Instruments, and I'm happy today to give you a tour to show you our facility and give you some insight on how some of the B.A.C. Musical Instruments are handmade right here in Kansas City. Well, to make anything, it's going to require ingredients, and the ingredients to make brass instruments require three forms of what we call raw material. You have tubing, solid bar stock, and sheet. And as you can see, there are various alloys that we use. The alloys will help dictate how an instrument will sound and feel to the musician based on how hard it is and other physical properties of that material. From these three raw forms of material, we create a musical instrument. The journey for making any brass instrument bell starts in a variety of different ways. Here at B.A.C. Musical Instruments, most of the bells we make are one-piece bells, and the process in which they're made is a long-standing tradition that goes back hundreds of years. This is a trombone bell pattern. This is what the bell starts as. We'll take a large sheet of brass and cut out a particular pattern. Each pattern for each bell is different, and there's a matched bell mandrel that we'll find out here in a minute. So once we take our pattern, that pattern has to be then folded by the artisan here. We'll take the pattern, gets folded, and as it gets tighter, we have a seam that's referred to. There are different styles of seam. This seam is called a butt seam, as the brass gets butted next to each other. And then that seam gets brazed, which is similar to welding. It's a lower temperature of welding where the brass gets joined together. After it gets joined together, we need to smooth that seam out. After that seam is smoothed out, the artisan will have to hammer into the shape of a bell. And there's lots of round of hammering. As you can see, this station here is the bell hammering station. Each time the bell gets hammered, the material will get hard. As the material gets hard and work hardened, it's important for the artisan to soften the material through a process called annealing, where with a torch the material gets glowing red. That allows us to continue working the material to stretch it further. And that process goes over and over again until we get to the desired shape, until finally it's put on a mandrel. We'll draw it down on a hydraulic piston, and then finally that mandrel is put on a lathe and spun to smooth out all of those hammer marks. That is truly a hand-hammered bell, and a style and fashion that was done hundreds of years ago, a tradition that we're dedicated to preserving here at B.A.C. Musical Instruments. One of the more recognizable features of a brass instrument today are all of the bends and crooks that you'll find. And a lot of questions we get when giving a tour is, how do we bend these parts? So what you'll see here is a trumpet bell that's been made, and as it comes off the mandrel, it's straight. But you'll notice that's not what a trumpet bell normally looks like. This is what a trumpet bell normally looks like. As when you're playing air, the air goes and passes through the bell. Obviously, you need to have a nice smooth bend. For hundreds of years, there have been different ways that artisans have bent brass. But one of the most recognized ways and used ways for hundreds of years is this stuff called pitch. This is where the expression pitch black comes from. This was commonly used hundreds of years ago to waterproof and seal the bottom of a boat. It was also used to waterproof the top of a house, a pitch roof. What brass artisans use this for is, after heat treating brass tubing, they would heat it up in a bucket and it would become liquid. They'd then pour this liquid into a heat treated straight tube that's been softened, and after the pitch dries and cools off, it becomes hard again. Now here you'll see a trombone main tuning slide that's been filled with pitch, which is hard right now. What that does, allows the artisan to bend it around a form. You see a bending block here, and that pitch on the inside prevents the bell from buckling or kinking, which is what would otherwise happen if there was nothing inside that bell. After the bell or whatever part has been bent, then the artisan will melt the material out, and then that material would be reused. Pitch has been used for hundreds of years, as has been things like lead, and even sand, hot sand had been used. Today, BAC Musical Instruments has embraced a more green solution that's more healthy for the environment, and that's what we've been using today, but these are the fixtures that we use to bend our parts. Ironically, the detail of getting an instrument looking beautiful and shiny is probably, well, it is the dirtiest job here in the factory. This is our buffing room. And what we have here is different various cotton wheels, and we have different compounds that come in different grits, like you might expect sandpaper, but these are very, very fine grits of compound. This is what you'd expect to find in a jewelry store that jewelers would use on fine jewelry. It's a very high level of skill that's required to polish and detail every little square inch of a musical instrument to make it look really stunning and beautiful. And that's what happens here in the buffing room. All right, I got Vinny here. How you doing, Vinny?
I'm good, Mike. How are you?
I'm doing all right. Vinny is going to demonstrate for us a process called drawing. And the drawing process is very critical for manufacturing a lot of what we do here at BAC with manufacturing brass instruments. What he's drawing specifically is a tapered part. And I'll explain in just a minute the difference between a tapered part and a cylindrical part. So what Vinny has here is a tapered mandrel, which is for a trumpet lead pipe. And then he has a blank, which is a raw piece of tube that we've prepared for this purpose. The blank tube, which is not exact, is going to go on top of the tapered tube. He's going to have it lubricated. He's going to put it into this hydraulic and draw it through a washer. Now the washer has been specially treated for this purpose, and as it draws through this hole of the washer will squeeze the brass onto the mandrel and give us the exact precise taper that we want. Let's see what you got, Benny.
Alrighty.
And there you go. And there's a custom trumpet lead pipe. Good job. As you can imagine, having so many various different sizes of tubes and ferrules and things like this would be really daunting to inventory from purchasing somewhere. So what we do is we have fewer raw material sizes, and then we draw the specific sizes that we need. So we have rather a lot of specifically sized mandrels and dies. So using that hydraulic drawing process that we just showed you with Vinny, we'll do the same thing with cylindrical tubes. And we'll have a precisely ground mandrel, and we'll have a precisely ground die, and we'll have that tube stretched over the hydraulic, over the mandrel, and through the die. And the mandrel will determine the very specific inside diameter, or ID, and the die will determine the very specific outer diameter, or OD. And that is how we have so many very specific custom sizes for our instruments. Every aspect of building a brass instrument is super important. But one of the areas that we really see as very critical is how are these instruments built and assembled? One of the things that we ensure is that there's no stress introduced in the build of the instrument. So we don't want to use any fixtures that would put stress in the brass, that are clamping things. That's going to allow the brass instrument to play very freely and resonant and responsive. The other thing is that the joints are flush and clean at the end as they butt up against each other, so that there's no turbulence interrupted that would create any disturbance in the airflow. When we're building the instrument, there are three varying forms of solder techniques that are used, and I'm going to tell you about those three right now. The most common form of soldering is called soft solder. This is what you'll find in most musical instrument repair shops around the world. Soft solder is the lowest melting temperature you'll find, and it's what's used in the final assembly of a brass instrument. So if you ever have a solder joint break, a finger hook fall off, or a pinky ring or something like that, it's usually going to be soft solder to the instrument. This is a very soft, malleable material, as you can see, and it requires a liquid flux because the melting temperature is lower. It's going to be between 600 and 800 degrees melting temperature. The liquid flux is going to clean and deoxidize the part, and it's going to help the bond between the soft solder and the brass itself. For a stronger joint, we need something that's going to be a higher melting temperature, and that's when we use something called silver solder. Now you can just see right away, silver solder is much harder, more flexible material. Silver solder requires an actual paste flux because the paste is not going to evaporate as quickly as liquid flux. The silver solder temperature is going to be, the melting temperature is going to be more between 12 and 1500 degrees. And it's going to be a more strong, stable material that we would use for an area like a brace point here, connecting a ferrule to a socket. The last type of brazing or soldering that we use is actually called a brazing wire. And this is actually bronze wire that's very close to the alloy of brass we use. This is primarily done in the bell making process. It's the highest melting temperature, and it approaches the melting temperature of the brass or copper itself. So it's very challenging to do this and requires a high level of skill, but it is the strongest material. And because the bell making process is so rigorous and goes through a lot of stress, it's important to have something super strong so that it doesn't break the seam during the bell making process. And those are the three basic ways and soldering styles of building a brass instrument. Perhaps one of the strongest assets that BAC Musical Instruments has today is the burning desire that all of the craftsmen have and the passion that they have for what they do. We draw inspiration from instruments like this old Earl Williams trombone and pour it into details like engraving. One of the last workshops in the world that has an in-house engraver that diligently hand creates this engraving on our own instruments. And he'll study old instruments like this. Each and every one of the artisans here at BAC Musical Instruments shares that same passion for the old world craftsman, and we try to take that and put it into the work that we do to provide the music community with some of the highest quality musical instruments. Whether it's a student instrument that you're starting in 5th grade or you're playing on the largest stages in the world, BAC Musical Instruments is for every stage.